Okay, this is Charles Sterling from Sterling Power Products. We're just doing another quick test on fridges. We were asked to do this by one company we work with. So basically the test today is to see whether these inland waterway fridges, which one performs the best. And obviously we're going to do the 240 volt one through the Combi again, just to compare figures to see, you know, if it's worth spending the extra money. So anyway, what we have here is a Waco fridge, 12 volt compressor fridge, 240 volt normal compressor fridge running through our Combi. Then we have, this is a Shoreline 12 volt compressor fridge and a LEC 12 volt compressor fridge. Basically they're all LEC fridges and they just replace the 240 volt compressor with a 12 volt compressor. So we're just going to do efficiency tests here to see what the numbers are, how they work. And basically what we have is our battery charger, which is running all the 12 volt. We have the Combi, and then we have amp hour counters on each of the products to see how many amps and amp hours they are consuming. So the first thing we've done here is put in, let's call it our turkey or our chicken. So that's one of our products that's solid. So it's very heavy. We've used it because we can get the thermal temperature easily from the color on the side, but it's a good lump of product to give some mass. And also inside we've put just 4 bottles of water in each of the fridges, just to give it a bit of mass to do the test right. So if we close everything up, the first thing we need to do is get the temperature of what the starting point is. There are freezer compartments in this one, this one, this one. There's no freezer in the Shoreline version. So I'm not going to put ice in because that'd be a bit unfair. So we're just going to do temperature drops. So we're starting off at a temperature of 23.8 degrees at the moment. It's in the middle of the summer. Let's just check there. Nothing's changed. So our starting temperature is going to be 23.8 degrees. Okay, so now we're going to close them up, get them running, run them for an hour and a half to 2 hours. I'm not sure yet. I have to go and do a few jobs. And but anyway, we will monitor the time, obviously, and take it from there. So all ready to go. Yeah, chicken and all in there. Okay, let's fire it up and go for it. So we'll just take some sort of measurements here. So well, just to give you some idea, this at the minute is pulling 4 amps, 4.2 amps. This is pulling 6.2, 3.7 and 4.5. So I'll just write those down. This one's just changed a bit. And just for starting amps, we'll call it starting amps, just out of curiosity, SA. Starting amps. So this one is now at 3.3. That's how many amps it's drawing at the minute. This one's 5.3, 4.1, and the bottom one is 3.98. So I call it 4. Okay, so having looked on the back, these two are pretty much the same compressor anyway. This is a 230 volt compressor. You can see it's taking more power because it's also going through this Combi. So on the startup this looks like a bad thing, but whether it cools more, in other words, does it do more work by taking more power than the extra power it takes, is irrelevant. So these figures will come out. So this is just to roughly gives you an idea of what size the compressors are. So I would say this is the lowest powered one, but maybe they have special things going on times, etc., that'll make it work better. The LEC one seems to be, the 240 volt one seems to be the most powerful compressor, but bear in mind it is also running through this here, which will add 0.6 of an amp to its consumption. We are taking that into account, by the way. So the whole concept of this is to see if you're fitting a Combi on your narrowboat, is there any point in wasting money on fridges? But as I said many times before, it's the quiescent current of the Combi. All Combis are not the same. Don't be thinking they're all the same by any stretch. The quiescent current is the key thing. This has got a very low quiescent current. That is the current it takes to run itself. This one's about 0.6, 0.7. Our other Combi, the 2.5 kilowatt Combi, is about 1.2, 1.3. But when you get up into other manufacturers' Combis, you can be up to 2 amps, 3 amps, 4 amps, in which all these figures would be wrong. So the quiescent current is the key factor to bear in mind when you're running a fridge through an inverter or a Combi. Also, your normal inverter, to run this fridge normally, if you just wanted to run it, you'd need about a 1,000 watt inverter, and your normal inverters would have about a 0.9 amp quiescent current. So this has been specially designed to have a low quiescent. Anyway, the proof is in the pudding, as they say. So we're going to run this now for an hour and a half to 2 hours, and then we'll divide how much temperature's dropped by how many amps, and I'll give you amps per temperature drop, and then we'll run it overnight and get this sort of long-term thing. So I'll leave you now for a little while this runs on. Okay, we are back now. We started at 12:10, it's now 12:40 to, let's see, finish at 1:40. Okay, so we've done an hour and a half. So an hour and a half, let's work out, first of all, how many amp hours we have used in 1.5 hours. So amp hours, and that's for 1.5 hour test. Okay, so what we're going to do now is add or count the number of amp hours. So this one here, let's start at this end then, the Waco. This one's got -5 amp hours, -6 amp hours, -5 amp hours, and -4.5, 4.8, sorry, 4.8. So 4.8, so let's write that down. That's -5. The Waco is, that's 5 amp hours, 6 amp hours, 5 amp hours, and just confirm, sorry, 2 amp hours. This one's used 2 amp hours. Inland is 2. Okay, so remember, this one doesn't have the freezer, this one has the freezer. So this one's -2 amp hours. So what we're trying to find out now is what temperature has it dropped. So you can see there's quite a lot of difference. 5 amp hours, 6 amp hours, 5 amp hours, 2 amp hours. So let's see how much work it's done. In other words, how much temperatures it dropped. So let's get some temperatures here. So in the Waco fridge here, I'm just measuring that thermal, that lump of stuff. So that is 17.7. Waco is down to 17.7. The LEC is 15.5. Sorry, the 240 volt one, 15.5. 15.5. Right, the Inlander with the freezer is 15.4. And that's the Inlander. That's 15.4. So I've got them around the wrong way. That is not 2 amps. That one was 5. This one was 2. So the Shoreline without the freezer is 2 amp hours. And it is dropped to 15.5. So that's quite interesting. The thing you need to be a little bit careful about, you can see the Shoreline has only used 2 amp hours, where the Inlander has used 5, and so has the other 240 volt ones. but this one doesn't have the freezer on it. So, you know, remember these other ones are concentrating the cold in the freezer box. So it's a very sort of difficult thing to compare these two together. But at the end of the day, I know for looking at the back of them, they've got the same compressor on them, and they're consuming the same amount of power. So when the compressor's running, so this is all to do with, I suspect, that you know, they don't have the freezer, the really cold section. But anyway, we'll carry on. So we'll work out the amps it's used to drop 1 degree, and we'll get that on there. I'll do the calculations on that. So the next test we're going to do, we're just going to run it now until tomorrow morning, and just let it all go right down to temperature, and we'll get a much better average of what the thing's consuming. In between time, I will work out the amps per degrees dropped, and you can see here almost straight away that although this model here through the Combi took 6 amps, it's dropped 2 or 1.5 degrees or 2 degrees more than the Waco one. But we'll do the figures. It's all about the maths. It's not about a personal opinion. So we'll switch off now, and we'll see you tomorrow morning when we you know, see what the 24-hour thing looks like. So it's now 1:40, and we'll have a go tomorrow morning and see what sort of figures we're getting there. Okay. Okay, just a quick update, having done a few figures here. So this is the amp hours used since we fired up the test 21 hours ago. So the Waco 12 volt compressor, 2.8 amp hours, but they did bring the temperature down lower, so 2.8 amp hours. The 240 volt fridge here through the unit, including the power used by the unit, was 2.5 amp hours. A little bit less than the Waco, but again, we didn't go down as low. Our thermostat is obviously set different. The Shoreline, without the compressor, which is the one down here, without the freezer, 1 amp hour. So that definitely is a clear lesson that if you don't want the freezing compartment, don't buy the freezing compartment. It's just that simple. Your fridge will use half the power. That's a lot. So that's one thing we've learned out of this one. And then the Inlander, which is this one, has the freezing compartment in it, and it has used this 2.8 amp hours. So the compressor ones, even the ones through the inverter, are 6 to 1, half a dozen the other one. Just the clear thing here is don't buy a freezer if you don't want it. And also, just don't even buy it if you think, well, maybe one day I'll use it. That's a lot of power. That's, you know, so I would get any of these without the freezing compartment if you don't want the freezing. Okay, so the other thing to bear in mind is prices. The Waco one is about £900. The Lec one is about 140, but you would need an inverter on top of that. The Shoreline, both the Shoreline and the Inlander, around the £550 mark. It should be worth adding on here that the Combi, which is this 1600 Combi S with the low quiescent, the Combi is, I think it's about £1,000, give or take. So the whole point of showing this is that you can literally save £400 up to £800 off the cost of the Combi by simply going to 240 volts. So okay, that brings us up to date to where we are. We'll leave this for another hour or so, and then we'll start timing for the next 24-hour test, which should be interesting. Okay. Okay, it's now Thursday at 1400. I've raised the temperature of the 2 units that were in the minus. I don't want them in the minus. So what I'll do now is I've switched everything off. I'm going to switch it back on again to zero the counters. Basically, this test is just, we're down to temperature. Now we're just going to run it for 24 hours, 2 days, 3 days, whatever. But we'll start off with a 24-hour. We'll do the maths for amp hours used over that time frame, which is the sort of long-term figures, and then we can run it for a day, 2 days, whatever. So hopefully we're above 0 degrees now, and I'm just going to switch everything on. So we're all starting from the start again. So the inverter's on, everything. So we'll just do a quick temperature check. Again, we're not really worried about what this temperature is going to be, just to make sure that we're keeping within, you know, it's the realms of what it's supposed to be doing. Okay, this one is now 6.1. So that's 6.1 degrees C, so that's come up quite a bit, which is good. This one is 7.4. Remember, these are all just to do with the thermostat settings, so we're not really, this one's still a wee bit cooler, but it's above 0 anyway, so that's 1.6. That's the Inlander, right, that's 1.6. And this one is the 5.4. Okay, so that's the starting degrees C's and on the temperature. As I say, it's not that important. It's just that we can check the finals to make sure there's been no big discrepancies there. So from what I understand, 6 odd degrees is about what you should have your fridge at, not your freezer. So all the counters are now at 0. That unit's working. That hasn't kicked in yet. That hasn't kicked in yet. And this one has kicked in, so that's 3.8. Okay, just leave it now for 24 hours, and let's see where we are tomorrow. And then if we want to leave it, may as well leave it all weekend as well, which will be 3 days. Okay, so that'll do us now. Okay, thanks. Okay, it's Charles Sterling Power, back again on the Friday morning. Rather than bore you doing the maths and everything in front of you, I've done the figures here, so I can talk more about the results rather than you sit and watch me doing figures. So taking the actual consumptions here, we have the Waco has used 30 amp hours. This one here has used 35 with the inverter. The Shoreline without the freezer has used where am I? 20, and the one with the freezer has used 29. So divide the number of hours in, and the Waco works out at 1.6 amp hours. The one with the inverter through it is 1.9 amp hours. The one without the freezer is 1.1 amp hours, and the one with the freezer is 1.6. So the key things here are the Waco versus the one with the freezer in it are both 1.6. So what that tells me is that there's really no difference in the insulation and the efficiency. So it's 6 of one, half a dozen of the other. One's 800 and something pounds, the other one's 500 and something pounds. You know, make your choice. The one running through the inverter, the Combi, has used 0.3 amps more than the other two units. But bear in mind, this is with the inverter on all the time. We haven't used the power saver mode in this. We just didn't want to skew the figures. So this is with an inverter or a Combi on all the time. The power saver mode would reduce that. But even with that on, you might be charging your mobile phone, you might be doing other stuff. So the inverter is on in order to do that. Your 0.3 amps difference, I would suggest that's an irrelevant figure on a boat. And then the other interesting thing is the freezer, the fridge freezer without the freezer, just the fridge only. The consumption is way down. I mean, you're down at 1.1 as opposed to 1.6. So it brings us back to the thing we worked out earlier on in the test, that if you don't want a freezer, if the freezing compartment is never really used, don't buy one. Buy them. All of these will be available without the freezing compartment. So if you don't want the freezer, don't buy it. It's definitely advantageous on the figures not to have the freezer. So in conclusion, there really is 6 of one, half a dozen of the other. The reason for this test from our point of view was to show that running inverters or fridges through inverters and saving yourself the money. In other words, if you're already putting a Combi or an inverter on your boat, do a simple maths. The key thing is, again, the quiescent current of the Combi. There's no point getting a Combi like our 3.5 kilowatt Combi is about 4 amps on a quiescent current. You really don't want to be running the fridge on that. However, this one's 0.6. Our normal 2.5 kilowatt one is 1.3. That's on all the time. If you put the power saver function on, that'll drop away back, dramatically back. So do the maths, but certainly if you're putting on either our 1.6 or our 2.2 on a narrow boat, there is no reason whatsoever why you shouldn't be using a 240 volt fridge. It just makes economic sense. You're going to save £400 on your installation, and you've got the Combi there anyway. That's fine. If you're using other manufacturers' Combis, get that quiescent current. So we're 0.6, 1.3, but something like a Victron's 1.8, you can get up to 2.5, 3.5. You're heading into the, do you want that extra consumption? Do the maths. It's primary school maths, work it out. So there's a little bit more consumption in this one by 0.3 of an amp, which I would suggest to use irrelevant. On the startup, so bear in mind this hasn't been used now for 18 hours. But if you were opening these doors, putting new stuff in and everything, all we were doing here really is testing the insulation. But when you actually go to the figures for when the fridge is actually being used hard, there is absolutely no difference in them whatsoever, except for the, again, the non-freezer version. But if you go to the original figures, which is where the compressor is working hard, remember the inverter looks better when the compressor is being used less, because the inefficiencies of the 12 volt compressor, or the inefficiency of the 12 volt fridges, is the compressor. So if you're just testing the insulation only, and you're just checking the heat loss, then the compressor is not being used very much. As a result, the inverter system looks a little bit worse. But that's just on ideal situations. That's not using the fridge. Once you start using the fridge, once you open the doors, and once you're actually using the compressor, then the efficiency of the compressor starts to become a relevant factor. Because the more you use the compressor, the more inefficient it is. The more inefficient it is, the more the figures swing towards the inverter. So that's why the earlier figures show you when the compressor was actually being used. And you could see the normal fridges were running at about 0.8 amp hours, where running through the compressor was at 0.7. So in actual fact, sorry, that's per degree drop. It was 2.5 amp hours versus 2.8. So the normal ones were using 2.8 amp hours. This unit was using 2.5 amp hours. And that's purely because the compressor was being used more. And the more you use the compressor, the more the efficiency of these things become irrelevant. So overall, it just seems that there are 6 of one, half a dozen of the other. The only one that stood out as mega efficient or a mega buy, again, was the non-freezer version, which is available in all of these units. It's not restricted to Shoreline. So I hope this information has helped you. And if you need any questions answered, just send me a text or give us a ring. Okay, thank you.